Federation and single sign-on are about reducing repeated logins by allowing systems to share identity trust rather than forcing users to authenticate independently to every service. In modern environments, people interact with dozens of applications daily, and repeatedly entering credentials is both frustrating and risky because it encourages weak habits and increases exposure to phishing. Federation changes the model by establishing trust relationships between systems so that authentication can happen once and be reused securely. This does not eliminate authentication risk. Instead, it concentrates it into well-defined flows that can be protected and monitored more effectively. The security value comes from fewer credential prompts, clearer trust boundaries, and centralized control over how identity is proven and reused. Before we continue, a quick note. This audio course is a companion to the CISS books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. Single sign-on allows one authentication event to grant access to multiple services, creating a smoother experience while reducing the number of times credentials are handled. Once a user successfully authenticates, that result is shared with other trusted services, which accept it rather than demanding a fresh login. This reduces password exposure because credentials are entered less often and into fewer interfaces, which in turn lowers phishing and keylogging risk. From an operational perspective, single sign-on simplifies access management because disabling one identity can immediately affect many downstream services. The trade-off is that the initial authentication event becomes critically important because if it is compromised, the attacker gains broad access rather than a single application foothold. Federation extends this concept by connecting identity providers and service providers across organizational or technical boundaries. An identity provider is the system that authenticates the user and asserts their identity, while a service provider relies on that assertion to grant access. Federation allows these systems to be operated by different teams or even different organizations as long as they agree on trust rules and protocols. This is common in cloud services, software-as-a-service platforms, and partner integrations, where local accounts would be impractical to manage at scale. The security challenge is that trust must be explicit and verifiable, because each service is relying on external decisions rather than its own authentication logic. When Federation is designed carefully, it enables collaboration without sacrificing accountability. Security Assertion Markup Language is a widely used federation protocol in enterprise environments, relying on structured assertions to share authentication results and identity attributes. In a typical flow, the identity provider authenticates the user and then sends a signed assertion to the service provider stating that the user has been authenticated and including relevant attributes such as username or group membership. These assertions are expressed in extensible markup language and are protected through digital signatures to ensure integrity and authenticity. Security Assertion Markup Language is particularly common in enterprise single sign-on scenarios because it supports rich attribute exchange and strong trust relationships. Its complexity, however, means misconfiguration can introduce subtle security issues if assertions are accepted too broadly or without proper validation. OAuth is not primarily an authentication protocol, but an authorization framework designed to let applications access resources on a user's behalf without sharing passwords. Instead of giving an application full credentials, the user authorizes it to perform specific actions, such as reading data or posting content. OAuth formalizes this delegation so the user, the resource owner, remains in control of what access is granted. This distinction matters because OAuth answers the question of what an application is allowed to do, not who the user is in a traditional authentication sense.
Confusion between authentication and authorization is a common source of design flaws, especially when developers treat OAuth tokens as proof of identity rather than proof of permission.
OAuth relies on tokens to represent granted permissions, allowing systems to enforce access without ever exposing the user's password to the application. These tokens are issued by an authorization server after the user approves the requested access, and the application presents them when calling protected resources. Because tokens are scoped and time-limited, they reduce the impact of compromise compared to long-lived credentials.
Tokens can be revoked or allowed to expire naturally, which supports better lifecycle control. The security of OAuth therefore depends on protecting tokens in transit and at rest, and on ensuring they are used only for their intended purpose. Mishandling tokens effectively turns delegated access into unintended full access. OpenID Connect builds on OAuth by adding an identity layer that enables authentication in addition to authorization. It introduces standardized identity tokens that allow applications to learn who the user is, not just what access has been granted. This makes OpenID Connect suitable for modern single sign-on scenarios, especially for web and mobile applications. By leveraging OAuth flows, OpenID Connect benefits from the same token-based protections while clearly separating identity claims from access tokens. The result is a flexible and widely adopted approach to federation that works well across different platforms. As with any identity protocol, its security depends on correct implementation rather than on the specification alone. Identity providers sit at the center of federation and single sign-on architectures, managing authentication and issuing assertions or tokens to relying services. They are responsible for verifying credentials, enforcing multi-factor authentication, and applying risk-based controls before asserting identity. Because many services depend on a single identity provider, it becomes a high-value target and a critical component of availability. Strong protection, monitoring, and governance of the identity provider are therefore essential. Any weakness at this layer propagates outward, because downstream services are explicitly trusting its decisions. Centralization simplifies management, but it also concentrates responsibility and risk. Trust in federated systems depends on signed tokens, certificate validation, and strict audience restrictions that define where assertions are valid. Digital signatures ensure that tokens and assertions cannot be altered without detection, and that they truly originate from a trusted identity provider. Certificate validation anchors that trust by verifying the signing keys and preventing impersonation. Audience restrictions ensure that a token intended for one service cannot be replayed against another, which is a critical control against token reuse attacks. When any of these checks are missing or misconfigured, trust boundaries collapse. Federation works only when every participant enforces trust validation rigorously and consistently. Token lifetimes are a key security parameter because they determine how long a stolen or intercepted token remains usable. Short-lived tokens reduce exposure by limiting the window in which an attacker can replay them, but they may require refresh mechanisms that introduce additional complexity. Long-lived tokens improve performance and reduce authentication frequency, but they increase risk if compromised. Choosing appropriate lifetimes requires balancing usability, performance, and threat models. Monitoring token use patterns can help detect abuse, but prevention starts with sensible expiration policies. Token lifetime decisions should reflect the sensitivity of the access being granted rather than default values. Redirect and callback handling is a subtle but critical aspect of federation protocols because these flows move tokens and assertions through the user's browser. Attackers may attempt to manipulate redirect parameters to capture tokens or redirect users to malicious endpoints. Secure implementations validate redirect destinations strictly, ensuring they match pre-registered values and cannot be influenced arbitrarily. Failure to do so can result in token leakage even when cryptography is sound.
These issues are common because redirect logic often appears simple and is easy to get wrong. Treating redirect validation as a security control rather than a convenience feature is essential. Scope and consent define what an application may access on a user's behalf, shaping the principle of least privilege in federated authorization. Scopes represent discrete permissions, such as reading profile data or accessing a specific service function. Consent ensures the user understands and approves what is being granted, which is especially important when third-party applications are involved. Overly broad scopes undermine security by granting more access than necessary, increasing the impact of compromise. Clear scope design and meaningful consent prompts help align technical permissions with user intent. This alignment is critical for maintaining trust in federated ecosystems.
Logout behavior is often overlooked, yet it differs across protocols and implementations and can leave sessions active across services. Logging out of one application does not always terminate sessions with all federated services, which can surprise users and administrators alike. Single logout mechanisms exist, but they are not universally implemented or reliable across all services. This means session management must account for residual access even after a user believes they have logged out. From a security standpoint, understanding logout semantics is important for risk assessment, especially on shared or public devices. Clear communication and appropriate session timeouts help mitigate residual exposure.
Federation centralizes identity decisions and reduces credential sprawl, but it shifts trust toward token handling and protocol correctness. Security Assertion Markup Language, OAuth, and OpenID Connect each address different aspects of identity and authorization, and confusion between their roles is a common source of error. Strong identity providers, strict trust validation, careful token management, and disciplined redirect handling are what make these systems secure in practice. Token lifetimes, scopes, and consent define the blast radius when something goes wrong, while logout behavior influences residual risk. When federation is governed well, it simplifies access and strengthens security posture. When treated casually, it creates powerful shortcuts that attackers are eager to exploit.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.